Hello. In this recording, we will perform some example problems using Kirchhoff's current law. And the objective is to be able to state and use Kirchhoff's current law to analyze simple resistive circuits. Okay, this is the problem we're going to take a look at. And it says sum the currents at each node in the circuit shown. Note that there is no connection dot here. So what does that mean? It means that this current is, the wire is like such. And it also means that this connection goes through this direction. Okay. Okay, so let's start with Kirchhoff's current law. Let's start with red. So let's perform KCL at node A. All right, and with Kirchhoff's current law, I like to do the sum of currents in is equal to the sum of currents out. So node A is right here. What's coming into the node? I sub 2, I sub 5, and that looks like it. So we say I sub 2 plus I sub 5 is equal to what's leaving. And what is leaving is I sub 1 and I sub 4. So it's equal to I sub 1 plus I sub 4. So if we want to get everything on the same side, minus I sub 1 plus I sub 2 plus, let's put I sub 4 next, minus I sub 4 plus I sub 5 is equal to 0. So the text will have just the opposite. They have I sub 1 minus I sub 2 plus I sub 4 minus I sub 5 is equal to 0. Both are correct. We just chose different directions to be positive or negative. As long as you are consistent, that's all that matters. So let's do KCL at node B. And B is right here. Coming in, we have I sub 1 and I sub A and I sub B. So I sub 1 plus I sub A plus I sub B. And leaving this node, we have I sub 2 and I sub 3. So I sub 1 minus I sub 2 minus I sub 3 plus I sub A plus I sub B is equal to 0. All right, let's move on to, let's use brown here. Node C. Coming into node C, we have I sub 4, I sub 3, and I sub C. So KCL at node C. Coming in, we have I sub 3 plus I sub 4 plus I sub C. And leaving, we have I sub B. So we can say I sub 3 plus I sub 4 plus, well, let's put B in next, minus I sub B plus I sub C is equal to 0. All right, one more node to go. Let's use purple. KCL at node D. At node D, we have nobody's coming in. Everybody's leaving the node. So we have I sub 5 plus I sub A plus I sub c is equal to 0. Okay. Now, I did mention during lecture that if this statement had not been made, then this would be one node combined. So let's analyze as though those two do have a connection and we have one single node there. So KCL at node CD. All right, let's change our color here. Going in, we have I sub 4 and I sub 3 and I sub c. So sum of current in equals sum of current out. So coming in, we have I sub 3 plus I sub 4 plus I sub c. And leaving this node, we have I sub a, I sub 5, I sub c, and I sub b. So I sub 5 plus I sub a plus I sub b plus I sub c. So you'll notice that I sub c is on both sides, which means that it will cancel. So we will remove it. And I sub 3 plus I sub 4 is equal to I sub 5 plus I sub a plus I sub b. Okay, I just wanted to show that to you so that you would get a good understanding of a combined node. So it doesn't have to be a pretty dot. It could look like this. All right. That concludes this example.